Hello, grade 10s. So before we start getting into the nitty-gritty of stoichiometry, where you guys are going to be required to calculate concentration and moles and percentage composition, we're going to go into a little bit of an introduction on chemical change, and then that's going to lead to balancing of equations. And finally, we're going to get into writing of formula and naming of compounds before we start the mole and stoichiometry. So just to clarify, and I don't know how much of this that you guys actually were exposed to in previous grades, so I'm just going to give a nice introduction on this. And if you are confused or you have any questions, please drop me a message and I will help you out. The first thing you need to be very, very cognizant of is the fact that there is quite a big difference between a physical change in a substance and a chemical change in a substance. Now, a physical change means that the matter has changed its phase. So the phases of matter, so whether it's a solid, a liquid, or a gas, that's all that it means. There's been no chemical change to its properties. Physical state has changed. That is it. So the arrangements of particles have changed, and you know this from phases of matter. Whereas the solid is what? Compactly placed together. Everything is close together. Liquids are spread apart, and gases are dispersed. Okay, so an example of this would be in the morning when you guys are boiling water, the water has changed from liquid phase to gas phase. The water, therefore, the kinetic energy of those molecules in that particular matter, the molecules of the matter, has changed. Because when we add heat to something, the energy of those molecules increases. So they move at a faster pace. Okay, it's increased because of the heat. So think about when you eat something, when you eat a sandwich, there's a chemical change because things have been rearranged during the chemical reaction to form a new substance. A chemical equation describes what happens in this chemical reaction, and that is what we are going to focus on. And that's why I'm just trying to make you see that when a new substance is formed in a compound, it might not be in liquid phase that it used to be in. For example, let's think about water. H2O is typically at room temperature, it's liquid. However, in combustion reactions, it's going to be a gas. Why is it a gas? There's a lot of heat involved in that reaction. So any chemical change is described by that chemical equation. It's telling the chemist, it's telling the person what happened. And we're going to look at different reaction types. And we're going to look at how different compounds are soluble or insoluble, how that relates to your chemical equation. Okay. So grade 10s, if you hear a Harido in the background, I do apologize. My pointer is looking at this Harido as we speak. He's about to go for him. Like Zeppelin, calm down. But to get back to the whole chemical equation conversation, from grade 9, I don't know if you remember what we said, reactants are on the left-hand side and your products are on the right-hand side. And what did I tell you guys in grade 9? It's the law of the conservation of mass. Whatever's on the left needs to be on the right. That matter doesn't just disappear in a closed system. It's different if you are, let's think about when you are burning a fire, okay? You've got a certain amount of wood. And wood is made up of carbon and hydrogen and a lot of other elements. Nitrogen's involved as well. That burning of that wood is not in a closed system. A closed system means that it is contained. Everything that the change of the solid wood into gaseous phase is contained. Those elements that are breaking apart are they kept within a particular volume and they're not escaping and going out into the environment. However, when you have a braai, what's happening? That system is no longer closed. Okay, the smoke that's going up into the atmosphere is not contained. So even though you're left with ash at the end of the brine, that mass, the chances are that mass is not going to be 100% exactly the same as when you started with just the wood. And remember also you added oxygen as well to the mix. And you might think it's a gas. How do we measure the mass of that? There is a way to measure it, and you're going to learn later on. So a chemical change has occurred when a reaction has occurred and a new substance is formed. Heat is often a catalyst to this chemical change. And this is what I want you to pay attention to. So all of that I'm speaking about now, it's not in your notes, and it would be advisable for you guys to actually have an examination pad and write down these things that I have just spoken about. Make little notes for yourself, because the notes are very, very concise and to the point. We haven't added any background. This is the background. So your evidence of chemical change is going to be a color change, element or your compound, the formation of a gas, the formation of a solid, a change in temperature, and a larger energy change than a physical change. So there's a lot more energy involved in a chemical change than a physical change. Okay. So, like I said before in previous videos, if you need to pause here and write down what you need to write down, or even go back and maybe include a little extra there as an introduction, please do so now. So grade 10s, during a chemical reaction, individual atoms are rearranged as a new compound is formed. And there are a few reaction types that you need to be introduced to that are going to help you to predict your products as well as predict the phases. There are more than, there's decomposition reactions, there's synthesis, and there's exchange, but there's also combustion reactions. We're not going to focus on combustion reactions because in all probability, it's actually quite easy to predict the product from a combustion reaction because there's a lot of heat involved and a lot of the products are gaseous. Decomposition reactions it's a breakdown of component parts to therefore you are left with either the elemental form or they are in ionic form. Synthesis reactions is to make or form something new, and it's usually elements that are involved in a synthesis reaction or compounds. Exchange reactions, there are two types. There's a single displacement reaction and a double displacement reaction. A single displacement reaction means that there are the swapping of cations and anions, which form a new compound, and then there is a byproduct like hydrogen or oxygen. Then for a double displacement reaction, there is a swapping of both components or three compounds completely. The cations and the anions swap completely, and you are left with two or three complete new compounds. So there's no byproduct, there's no element or ion that's by itself. Okay, so you guys just need to kind of like write these down and maybe make notes underneath them, because these reaction types are really going to help you predict how the products in your chemical equation. Then what I've added onto the slide is an actual, it's almost like your own personal glossary of terms when it comes to balancing of equations. The first thing you need to know is that when you put in the phase of an element or compound, it needs to be in italics, it needs to be in subscript, and it needs to be below the compound. So solid, liquid, and gaseous are all going to be in italics, and they're all going to be in lowercase. What is aqueous? Aqueous is when a solid is dissolved in water. All right, so any solid that is in water it's going to form an aqueous solution. Then we speak of or ions that are dissolved in water. That's an aqueous solution. It's not a pure water. Then a solid precipitate. What is a precipitate? It's the formation of a solid or solid substance, and that is represented by an arrow. And we learn about precipitation later on this year. But precipitates are the products of ionic exchange. gaseous product is going to be represented by an arrow going upwards. The arrow going across between the reactants and the products is going to be, it means products or producers or yields. Don't give me the equals mark. I don't want to see that at all. Arrows that are in two opposite direction means that the reaction is reversible. Then if you see a little delta sign above the arrow, that means that heat is required for the reactants to actually combine and for chemical change to occur. The pressure at which a reaction is carried out is not necessary. You guys don't need to know that right now. That's down the road. As well as temperature. I don't want you to stress about those two. The last two is there's sometimes a chemist will put the catalyst above the equal sign. So what is a catalyst? A catalyst is usually an element or substance that speeds up the reaction, the chemical reaction. So like manganese is often used as a catalyst in some reactions. Then I also want you guys to know what um, um, when we use electricity to break down a compound, okay, electrolysis, that is electricity, and lysis means to break down. You need to know that, okay? Because a lot of the time we use heat, light, or electricity to break down products. So please write this in, make your own little table, and we'll carry on to look at each of these reactions in a little bit more detail. So decomposition reactions are the first ones on the list, and there's two images here that show it quite nicely. It's very simple, grade 10s. It literally AB is broken down into A and B. So when you have sodium chloride, and look how we've made the chlorine smaller than the sodium, it is broken down or decomposes into chlorine gas and sodium solid because it's a metal. Elemental sodium is a metal, so it is solid. Most metals are solids. Another example is how they sometimes write it as A equals to B plus C. So here we have calcium carbonate, solid compound, limestone, that heat is added to this calcium carbonate, and what happens? You are going to get calcium oxide, which is a solid, and you're going to get carbon dioxide, which is a gas. So in these decomposition reactions, a single compound breaks down to give two or more simpler substances. So let's think about hydrogen peroxide. It is it decomposes, sorry, I'm tongue-tied, into oxygen quite a lot. That if we add a catalyst, usually it will decompose to water and oxygen gas a lot quicker. Okay, so an energy source is used in this situation. Just like I said before on the previous slide, it's heat, light, or electricity breaks down the bonds of the compounds, and that's what's going on. You're breaking down the bonds of the compound. On the flip side of the coin, you are going to get a synthesis reaction, which is opposite from a decomposition reaction, because these reactants are reacting to form a new product. So during a synthesis reaction, there's a change in the number of molecules. There's a change in the molecules. That doesn't mean there's a change in the atom and mass. It still remains the same, but sometimes the molecules are not the same, guys. So think about iron oxide, and we're going to get to iron oxide's chemical formula or chemical composition a little bit later, and you see that the molecules have changed, but the actual mass and the atoms are the same. They've just been rearranged. Okay, so I've given a few examples here of a synthesis reaction. That's photosynthesis. Involves carbon dioxide and water. Water is hydrogen and oxygen. Salt is sodium and chloride, well, that particular type of salt. And then the general form has been written down for you. So once again, please write this out for yourself. Have a little summary section. You don't necessarily have to have essay or paragraph fashion notes. You guys can make a mind map, whatever works for you, whatever's going to help you. The third category on the list are your exchange reactions. And like I said before, you get your displacement, single displacement, and then you get double displacement. There's a nice little table that we've added over here for you guys to just take and maybe adapt into your own form. But these reactions are those in which the cations and the anions, remember, cations are your metal ions, okay, and the anions are your non-metal ions, okay, that were partners in the reactants are interchanged into the products. In exchange reactions, the products must remain electrically neutral. So what's happening here is, just like I said to you before, in nature, everything wants to have balance. Everything wants to be equilibrium. And it's the same here. There needs to be an overall neutral charge. There cannot be a positive, the substance cannot be, or the neutrally charged compound cannot be positively charged or negatively charged. It has to be neutral, 100%. So they have to even each other out in charge. And that's going to come into play when you start writing formula, because you guys need to play with the number of atoms so that the charge is neutralized. We'll get to that a little bit later. There are two examples here. You've got magnesium and hydrochloric acid. Okay, and what's happening here? This is a single displacement reaction. So what's happened is that the magnesium metal has hijacked the chlorine, and hydrogen is the byproduct. So that's a single displacement reaction. Then you have aluminum sulfate, okay, plus barium hydroxide is going to form aluminum hydroxide and barium sulfate. So can you see how the cations and the anions have completely swapped around? And that would be your double displacement reaction. So like we said before in the beginning of the video, I spoke to you about how in a chemical reaction requires a lot more energy. And that's why we're going to get to this whole energy thing now. There are two different types of chemical reactions, or sorts of chemical reactions. We've done the types already. You get exothermic and endothermic. All right, so we speak about, in science, we speak about energy being absorbed and energy being released. So now there's a lot more energy that's being released from a chemical reaction. That's exothermic. So that requires, there's a lot of fire, that's explosions, there's a lot of things going on here. Whereas when more energy is absorbed than released, this is endothermic. So that would be like less photosynthesis. More energy is being absorbed. When you bake bread, the ingredients that are in your batter are absorbing the energy, the heat energy. When you cook an egg, water and evaporation, it has got to do more with absorption than release. So just make a little note for yourself here so you know what these two terms are, because we might ask you later to identify if a reaction is exothermic or endothermic. So on this slide, I have literally just found this while I was Googling, and I was trying to find something that would contextualize these type of reactions for you. Now, I'm sure you guys never played Super Mario, but I played Super Mario growing up, so I'm using the Super Mario as a metaphor for these type of reactions. Okay, so we've got the first one here, the synthesis reaction, is when Mario, he is going to use that magic mushroom, and guess what? He is going to become bigger. We have decomposition, which is a breakdown of our villains. We have a single displacement where, guess what? We have Luigi, he's by himself. That is my byproduct. That is the hydrogen or the oxygen. And then we have double displacement where the partners of those compounds have completely swapped. All right. So, and there's a few examples there of actual chemical equations that you guys can maybe write down for yourself under each of these little headings. It might just be a nice little summary for your notes. I want to just end off by mentioning the law of conservation of mass again, guys. This is incredibly important, and it's going to come into play later on when you work out relative molecular mass, when you work out any sort of concentration, it is very important. Okay, mass ratios. It's very important that you have this just in the back of your mind, that when it comes to the reactants and the products, it's going to be the same in a closed system. The examples we have here is we have silver nitrate and we have sodium chloride. And once that precipitate is formed, that silver chloride, because there was an exchange reaction there, okay, they have exactly the same mass once the reaction has taken place. Okay, the silver chloride is my solid, whereas my sodium nitrate is going to be in aqueous solution. Then we have the other example I've added here, and you guys have all done this, you did this in grade 8. It's the sulfur and iron practical. You have two completely different elements, and they come together and they form a new solid that isn't magnetic. And here again, 88 grams of product, whereas before we had the same amounts. So it's very important that you realize reactants and the products in the chemical reaction, the total mass will be the same at any point in a closed system. The closed system part is the most important section here, guys. Let me just get, my highlighter is not working. There we go. The closed system part is the most important thing that you need to recognize here, because we could evaluate you by asking you a question regarding the law of conservation of mass that's not in a closed system, like I used for example at the beginning of the video. So just bear this in mind, keep this in the back of your mind, and in the next video we'll start working with balancing of equations again. Have a great day, and we'll see each other soon.